শুনতে পাচ্ছ আমার কথা?
হ্যাঁ হ্যাঁ স্যার, আওয়াজ আসছে।
ক্লিয়ার?
হ্যাঁ স্যার, ক্লিয়ার আওয়াজ আসছে।
ভেরি গুড। সো is it visible?
Yes sir, visible.
Okay. So probably at the last class, that was also first class, the last of the last class. I have started that the instrumentations having relations with some particular kind of control systems. I told you that the most important control system is the feedback control systems, right? If my voice is not audible, let me know. Huh?
Okay,
So
sir.
in last of my last class, I said that there will be some control scheme which is very important in our fundamental of instrumentation. Even in case of instrumentations in future, which we will see in industrial instrumentation, process control, advanced process control, whatever it is. The basic concept of the instrumentations for control scheme will be feedback control scheme, right? Or feedback control systems. And there will be also other control systems like fit for control system. I have given a picture over here where you will find that the energy or the material input to a particular systems by these directions. And then there will be systems or process what disturbance also another input to my systems or process. Then we will find some control variable parameter that is called output, and that output is fed or checked by a measurement systems, and then that measurement system sent to a particular actuator, a comparator. Better, it is called comparator. Comparator compare that output signal if it is reached to the reference signal or it is at par the reference level, then it will send a zero signal. Otherwise, there will be error signal. Error will be plus minus. Which one will be sent to the control element? Which will be sent to the control element. Then that control element decide how much quantity of material or energy should be supplied to the systems. Should be supplied to the systems. Is it clear? Get this idea very clearly. The energy and material, these are the input and these are the output. What is the middle of the system? This is system or process. This is system or process. And this one is also another important thing is actually disturbance. Disturbance, definitely there will be certain kind of disturbance which you have to allow, and you have no control over the disturbance will come automatically. What you have to do, your control scheme, your systems should be smart enough to handle the disturbance. How the disturbance will be handled? Look, you can control this part, you can check this part, you cannot control this part, so let it enter in the system process and influence the or output variable. Once the output variable will be influenced due to the disturbance or might be due to the excess in material inputs, then that value will be measured and sent to the comparator will decide there should be a certain error. That error mainly might be the excess input or the disturbance. Okay. So due to what there will be certain kind of error. Error might be plus or minus, and that error will decide that what should be the control signal. What should be the control signal which actually control the material or energy inputs. Okay. If this will be input, we can change the gain of this process or systems, and we will find a stable variable output. This is feedback. This is feedback systems. The feeding back part actually this part actually feeding back part, and this part is feed forward part. This is feed forward path. Where you estimated that this will be the process gain. This will be the process gain, and what you have to do, you have to give some material or energy input to the systems, and according to your pre-calculation, there will be certain process gain, and which will give you the output considering the disturbance. This is simple state equations, like this is the input and this is another input. Okay. But when you are getting part of that output checked by some measurement systems, then sent to back to the comparator, and the inputs will be controlled according to the set value. Set value. Set value means the reference one. Set value means reference one. So this is measurement part. This is a comparator part. This is your input. The whole system is called feedback systems. You will find a stable output. Stable output. Okay. This is actually
Sir, sir, why is there a plus minus in the output signal but only a plus in the reference signal?
only plus in the reference signal means what is reference signal? Suppose like consider the example that you need to boil water in 80 degrees centigrade, not in 100 degrees centigrade, right? So your set value is your standard. Reference value is 80 degrees centigrade. To get that temperature, you have to supply certain energy to your gas oven. So your here I'm going to say here your set value is 80 degrees centigrade. So for what you probably started X amount of energy you started burning, and for what your process that process consider as like a cooker and your gas oven will give you the give you a certain rise of the temperature of the water inside the chamber or process. Okay. Might be that signal is 60 degree that parameter of the or temperature of the water is 60 degrees centigrade. As you have burned X amount of energy, or spent X amount of energy, or X amount of suppose the LPG gas is burned, and due to what the temperature of water rises up to 60 degrees centigrade, and it's obviously consider some environmental temperature, that is disturbance. Okay, suppose in winter when you burn X amount of LPG gas or X amount of energy, you probably not get 60 degrees centigrade. It might be 58 or 59 degrees centigrade. But due to environmental change, might be in summer you will burn that X amount of LPG gas or X amount of energy, you will find 60 degrees centigrade because the disturbance is there. Okay. Is it clear? Then what you have done, you inserted a thermometer. You inserted a thermometer in the boiling into the boiling water pan. or cooker or chamber, whatever. So the thermometer gives you a signal temperature is just 60 degree. What is your temperature? 80 degree. So that 80 degree should be minus from 60 degree. Okay, that 80 degrees should be minus from your 80 degree centigrade. So what is your requirement? You require 20 degree centigrade more temperature of the output. So according to what the error signal will give to your control scheme. So the difference is 20 degree centigrade. That is difference means delta. 80 is always considered will be plus. Compare with what? There will be some. This is not a plus actually. There will be a plus means the set value is here. Set value is here. The output value this will be negative or positive. Suppose sometimes temperature is 80 degree, 100 degree centigrade. What do you have to consider? The 100 degree should be minus. Then what should be there? Minus 20 degree centigrade. So if the temperature is 60 degree centigrade, there will be plus 20 degree centigrade. If it is temperature is 100 degree centigrade, there will be minus 20 degree centigrade. That two signals might be here. That two signal might be here, or I mean that two signal means either 20 degree centigrade positive or minus 20 degree centigrade positive. That will be here, and according to what the control system will generate output and allow more LPG burning, or more LPG will burn, or less LPG will burn. Now look over here. 80 is always positive here, right? 80 is always positive here. Am I right?
Yes, sir.
What I am finding that the 60 will be subtracted or 100 will be subtracted. If 60 will be subtracted, the result will be positive. 100 will be subtracted, minus. Result will be minus. According to what the plus minus error signal will come to the control element. Now you can say, sir, how can it be possible to get a minus 20 degree or plus 20 degree centigrade? This is here, the R plus minus O. R plus minus O means I am giving a continuous reference signal. Suppose there will be a op-amp system. Have you studied op-amp?
No, sir.
So you will study analog electronics. The op-amp systems where adder will be another legs. This is the adding legs, and the signal is negative, it will be added. If signal is positive, it will be again added, and finally you will find a output signal. That is output of comparator. Which we said is the E here. E stands for error. As it is a comparator means let me show you a basic comparator circuits. Have you studied these things earlier in basic electronics?
No, sir.
No, sir. Actually, this is operational amplifier or op-amp. It's actually made of different kind of transistors. You probably studied the differential of amplifier, where two transistors you consider. There are input IB1. There will be another input IB2, and there will be a load resistance L. L will be IL. IL might be IC1 minus IC2. Have you studied that kind of circuit earlier? Have you studied that kind of circuit earlier?
No, sir.
No. No. You have not studied that circuit.
Sir, we forgot, sir.
That is might be the answer. I mean, you have you studied transistor?
Yes, sir.
Yes, sir.
So you have studied BJT transistor. What is the advantage of BJT? Why we used to study BJT transistors? What is the benefit of transistor? We using the transistor, we can design amplifier. Okay, amplifier means what kind of amplifier? We amplify a particular kind of signals. It might be current signal and it might be voltage signal. Okay, a transistor itself is amplifier. It's a current amplifier. It's amplify the current signal. What is the input current signal in transistor BJT? Normally, what is the input signal of a transistor BJT? IB.
Base current, sir.
Yes, base current. IB. And what is the output current? IC.
Collector.
It might be IC or IE. We normally consider IC. It's depend on the circuit. If common emitter, the circuit is common emitter. Like here, I designed common emitter circuit. Then it's IC. Output current. Okay. So IC and IB, there will be certain relations that beta IB equal to IC. Beta is the current gain or transistor factor. Can you remember these things?
Yes, sir. Yes.
Fine. So you look over here, two transistors set like in I mean each opposite configurations, and what we have done, we connect a resistance across the two collector. Two collector means two collector of two transistors. Okay. We allow IB1 to activate the transistor 1 and IB2 to activate the transistor 2. Okay. Now it's depend on the which current is bigger. If IB1 is bigger than IB2, then the current difference will be IB1 minus IB2. If the transistor are same configuration, they have the same current gain beta, then the output current will be beta IC1 minus IC2. Am I right? Who wants to answer? Let me know first. I'll ask few questions here. I'll ask you few questions from here. Let me know who wants to answer. Yogesh Tiwari. Yogesh Tiwari. Sagar Chaudhary.
Yes, sir. Yes, sir.
Okay, you just answer me. I will ask you questions here. You just answer me.
Yes, sir.
If you can answer, then it's not a problem. Huh? Don't be shy. If I am going to draw roughly like a picture of transistor, BJT transistor, it might be base, it will be collector, and it will be emitter. Am I right?
Yes, sir. Yes, sir.
Okay. Now I am making it a common emitter.
Yes, sir.
If the load is RL, then the across the load the voltage will be VL.
Yes, sir.
VL equal to RL IL,
Yes, sir.
and IL equal to IC.
Yes, sir.
Am I right or wrong?
Yes, sir.
Sometimes I used to write wrong. Be careful to answer yes.
Okay, sir.
If anything I have written here wrong, anyone from you will say that sir it is wrong. It should be like that. Okay, I am expecting this call from you.
Yes, sir.
So look, this is simple a transistor I drawn. Then when I am going to make a differential amplifier, what I have to do? I have to do the same transistor here. I have to find the same collector here. Same emitter here, and this will be grounded, and another part is collector. Another part is collector. Another part is input B, and B will be given by another source. Okay, like this. Look, the beta is same here. Now this is IB1, this is IB. For what? This will be IC1, and there will be another current component, that is IC2, and this is RL, and this is VC. So the load, across load, the voltage is VL. VL is here, RL and IL, and ILA here will be IC1 minus IC2, depending on that IC1 is greater than IC2. Am I right? considering that IC1 is greater than IC2. Okay. And what is IC1? What is IC1? IC1 is beta IB1. What is IC2? Is beta IB2. So I equal to beta IB1 minus IB2. So what is VL? VL equal to beta RL IB1 minus IB2. Okay. I am not considering any minority kind over here. I just make that mathematics simple for our understanding, for our remembrance. So here VL is the output across the load and which depend on two input currents. So if you go back to the input current, if IB1 is greater than IB2, then we can say the VL will be like that. Now my question is that if from where the IB1 or IB2 coming out? From where IB1 or IB2 coming out? Huh? Baba, Saurabh, Yogesh, Joydeep. Huh? From where that IB1 or IB2 coming out? From this source?
Sir, VB1 and VB2.
Those are the source from where IB1, IB2 coming out, right? So current source means what is that? The current source means the VS1. If this is source 1, by its internal resistance RS1. Similarly, this is VS2 by RS2. RS2 means resistance across that one. If you're going to consider is VS2 minus VBE. That's the voltage, right? VS2 minus VB. VB1 by RS1, RS2. Similarly here, VS1 minus VBE by RS1. This is VBE, and as we say that both the transistors are similar in configuration, so VB here are same, VB are same here. So VB same means that VB part will be subtracted from the source voltage, because this is probably Kirchhoff voltage law you studied, and internal resistance is RS1 in this circuit. So the current IB will be VS1 minus VB by RS1. Similarly here VS2 minus VB by RS2. Am I right? Am I right? চলো তোমরা ঘুমিয়ে পড়লে না, তোমাদের মনে হচ্ছে এটা রং না কি হচ্ছে, সমস্যাটা বলো। অঙ্কিত, Ankit?
Yes, sir.
So what is your problem? To say yes or no?
Sir, it just took time to on my mic, sir.
Why? Have you not studied the transistor? It's a simple, no, I have done nothing more. It's a very class 10 level mathematics. Somoji,
Yes, sir.
can you verify whatever I have written here? Can you check it? Am I right or wrong?
Yes sir, but আমার একটা ডাউট হচ্ছে স্যার VS1 যেটা আছে সেটাই তো স্যার VB হওয়া উচিত।
কি বলছো?
বেস এমিটার ভোল্টেজ যেটা সেটা তো আমরা যেটা সাপ্লাই করছি সেই ভোল্টেজটাই হবে।
আবে বেস এমিটার ভোল্টেজ মানে কি, ভিবি মানে কি, ওখানটাতে ডায়োডের ফরওয়ার্ড বায়াস হয়েছে। ফরওয়ার্ড বায়াসের ডায়োডের থ্রেশহোল্ড ভোল্টেজটা কি?
আচ্ছা ওই 0.7।
হ্যাঁ 0.7, এখানটা ফিক্স তো, এটা তো ফরওয়ার্ড বায়াস, ওটা তো রিভার্স বায়াস।
আচ্ছা 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 ওই ভোল্টেজটা ঠিক আছে।
তো ওই থ্রেশহোল্ড ভোল্টেজটা তো মাইনাস করেছে। তো দুটো সেম ট্রানজিস্টর নিয়েছি means it's made of germanium or silicon. All the parameters same means VB will be same, the doping constant or concentration will be same. So the VB part is same. So if you consider this is a simple loop of Kirchhoff voltage law, then equally you can say that this is a simple Kirchhoff's law. There is the voltage drop and there is another voltage drop. Resistance means the resistance across source, and the resistance means diode resistance. Here is the RD. As it is a forward bias conductance, so after threshold voltage there will be a breakdown or the huge current will come out. No? So RD, the diode resistance will be negligible with respect to the internal source of the voltage source. If internal resistance of the voltage source is 1 ohm or 2 ohm or 3 ohm, then once the diode will be conducting forward bias, then the resistance across diode is only few micro ohm. So which is not be in considerations, right? So the voltage here is this voltage and this voltage. So if you are going to say current, then this voltage actually the absorbing side. So the voltage, resultant voltage is source voltage minus this voltage by the resistance will be the current. A simple a loop. There will be another voltage plus minus, there will be another voltage plus minus. And this is VS1 and this is VBE1. And the resistance is suppose is RS1. Then the current will be, if VS1 is greater than VB1, definitely VS1 minus diode voltage, forward voltage VBE by RS1. This is current. And it's simple series circuit at a two voltage source such a current control, right? That is IV. So this is called differential transistors. What I am to mean here, the two voltage drop in transistor 1 and transistor 2 at their base are subtracted to produce the output load. To produce the output load. Definitely the gain or amplification factor is important over here. That should be depend upon the calculations. But the whole transistor is doing actually amplifying the differential input. Amplifying the differential input means IB1 or IB2 or VB1 or VB2 or VS1 or VS2, whatever. The VS1 minus VS2 or IB1 minus IB2 or VL or V1 minus V2. So that is the difference of the voltage or difference of current, which is actually amplified here by certain gain and produce a load current. So transistor is a current amplifier. Here two transistors connected such way which can amplify the difference of two input current, and produce an output current. So that's why it is called differential amplifier. That's why it is called differential current amplifier. Am I clear?
Yes, sir. Yes, sir.
স্যার আউটপুটটা কোথা থেকে নিলাম একটু বলুন।
আউটপুট তো দেখো, আউটপুট যখনই আমরা সার্কিটে আউটপুট মাপবো মানে একটা রেজিস্ট্যান্স কানেক্ট করব, আমরা রেজিস্ট্যান্সের অ্যাক্রস ভোল্টেজ দেব। আমরা দুভাবে আউটপুট দেখতে পারি। হোয়াট আর দ্য ইনস্ট্রুমেন্ট উই ক্যান মেজার দ্য আউটপুট? In electronic or electrical system, we have only multimeter to measure the output. What will be my output? Either it will be voltage or it will be current. Basically, everything is current, nothing is voltage there. Once we can produce a barrier across the flow of electrons, then we will find the voltage. Others there is no existence of voltage drop, right? If we allow a current passing through a superconductor, definitely the loss will be zero. So we cannot measure the voltage. You will find the voltage zero, but current it might be 1000 ampere because no resistance is there, so you will not find any voltage drop. So voltage drop will be zero. So what we want to do? We always want to measure the current flowing through a resistance. That's why the voltmeter are connected. Voltmeter are connected across. Beta, voltmeters are connected across the resistance. Am I right? What happened? The inside resistance of the voltmeter is negligible. Inside resistance of the voltmeter is
Negligible, sir.
right. That means low impedance. As it is low impedance, current always travels to the low impedance path. Current always travels through the low impedance path. So there will be no current. Most of the current pass through the low impedance path. Okay. Once it will pass to the low impedance part, we will find there will be a magnetic coil, magnetic field. When current passes through the magnetic field, there will be a mechanical deflection by Ampere's left-hand rules. Right? So we will find a pointer will move. A pointer will move and indicate the current. Actually, it moves and fixed a particular point. And that point is why it is fixed to a particular point. The electric field created by the flow of electron. Electric field created by flow of electron through the conductor. Right? So more flow of electron, more electric field will be created because inside the magnetic field is fixed. Permanent magnet are used, which is always create the same magnetic field. Then you will find how can we find the variation of the voltage? Actually, more flow of electron create more electric field, or less flow of electron create less electric field. Finally, we will find according to the electric field variation within a fixed magnetic field, the mechanical deflection. That mechanical deflection will be considered the indication of the voltage. Okay. Anyhow, this part you should study in circuit theory as well as analog electronics in details. My question is that this is a simple thing I need to know, inform you about the differential amplifier by a transistor. But when you will find that 40 number or 12 number of transistor, minimum 12 number of transistor are considered to construct a differential or amplifier, operational amplifier. Now this is come to another IC. This is probably first IC. Earlier the transistor you studied is the electronic component. First electronic component you studied is semiconductor, that is diode. You studied the first semiconductor device is diode, right?
Yes, sir.
Next you studied Zener diode. That PN junction having certain kind of characteristic breakdown or Zener breakdown or avalanche breakdown. It sometimes produces huge current in the breakdown regions according to what your knowledge of semiconductor physics developed or updated by one step, that is Zener diode. Second time you again updated your knowledge by Schottky diode. Where peak reverse voltage is less, the diode is smart, the doping is concentration is changed. Such way the efficiency of the diode is more here. The barrier layer might be low, target is produce huge current. Might be the semiconductor in structure, but when we will start conducting, it should behave like a conductor. So the target is reached by a Schottky diode. Later on, the component is amplified. Two diode PN, PA are clubbed or sandwiched. Produce another component is transistor, right? NPN or PNP, right? This way, your knowledge in semiconductor physics is developed. You studied to know that PNP transistor or NPN BJT transistor. Definitely, before this one, there is another semiconductor device that is called UJT, Uni-junction transistor. Well, you studied UJT. You probably introduced with the UJT, but that works with a similar person. Anyhow, the next part is the BJT. The BJT is bipolar junction transistors, and bipolar junction transistor, what I explained here is like that. And later on, you probably study field effect transistors, where the voltage will be input, current will be output. Okay. Now all the transistor components are sandwiched or embedded in a particular IC. The first IC comes to your life is 741. 741. What is 741? 741 is the operational amplifier. Operational amplifier normally noted by this triangular sign. What two input here? Consider input negative inverting terminal, minus means inverting, and plus means non-inverting. Why it is non-inverting? V input is here, or if 1, then output will be here minus 10. V input is a minus 1, then output will be plus 1. And whatever the input, it will be inverted. In details, that part will be discussed in analog electronics. If you not get it clear, you come to me, I will help you to understand. But this is the internal, more or less, working function is the inverting terminal. If you put 1 voltage in inverting terminal, plus 1 voltage, if you put this minus 10 voltage output, if it is a minus 1 voltage in input, then it will be plus 10 voltage, or minus plus 1 voltage, then it will be minus 10 voltage. But in non-inverting terminal, if you put here 1 voltage, it will give you plus 10 voltage. If you give minus 1 voltage, it will give you minus 10 voltage. So there is no inversion in output, so it is called non-inverting terminal or non-inverting inputs. Okay, this is true input of a operational amplifier. Now my question was that when I was studying a comparator, it is simple a comparator. If you give here 2 volt, if you give here 1 volt, output V0 will be definitely, this one is the bigger, this one is the bigger, this one is the lesser. So output will be AD. AD means the differential gain into 2 volt minus 1 volt, or my V1 minus V2. So V1 minus V2, this is V1, this is V2. V1 minus V2 means what we are considering, inverting terminal is dominating, non-inverting terminal is dominating. Definitely output will be opposite polarity. So whatever the output, it should be minus in opposite polarity, as this is inverting operations. So 2 volt here, 1 volt here, difference is 1 volt, AD gain, and that output will be minus AD. And normally the gain here is AD in open loop gain of 741 IC is 10 to the power minus 6. 10 to the power plus 6. So you can imagine the output voltage will be 10 to the power 6 voltage. Is it clear? So you gave here 2 volt in inverting terminal, 1 volt in non-inverting terminal. You got output is 10 to the power 6 volt. Okay, that means you can enlight the particular your area or your village or your town. Just simply having a op-amp which can amplify a differential input voltage. 10 to the power minus 6 volt means a huge voltage. Am I right? Are you all sleepy right now? If you are all sleepy, then I will stop my shouting.
Yes, sir, you are right.
So 10 to the power 6 volt will be the output. Am I right? Your guess is that?
Yes, sir.
Mathematically, I am right, but practically, I am
minus.
not. No, practically it should be minus, right? It should be minus. But mathematically, I am right that the output voltage is 10 to the power 6, because mathematically is saying this one. But practically, there is a law of conservation of energy. law of conservation of energy. I am giving 1 volt input side, I will get 10 to the power minus 6 volt output side. It violates the law of conservation of energy. Okay, so we will find that it will produce a maximum voltage according to what we have, according to what we supplied to activate the IC. So we will find there will be some bias DC minus 10 volt and plus 10 volt. Plus 10 volt. That 2 bias voltage will be here, due to what the output will saturate. Might be it is 10 to the power 6, but it will be limited by the negative voltage. Might be it is a plus 10 to the power 6, it will be limited by plus 10 volt. So this is operational amplifier. It's purely not part of your analog electronics, which is not in my discussion. My discussion is simple here comparator. My discussion simple here is comparator.
Sir, if we need 10 volts, sir, we are also providing the same 10 volts. So then what's the help of the amplifier?
Very good question. Very good question. So we are supplying 10 volt DC, but we are having 10 volt output by 1 volt input. What is the supply? Look, in case of transistor, what you done? You activate the transistor by what? Plus VCC minus VE. Am I right? In BJT transistor, what you did? You have said, sir, this is transistor. Is that a passive component or active component? Is that a passive component
Active.
or active? Active. Why it is active component? Why it is active component? Huh? Because a simple transistor, if connecting input voltage, the transistor will not work. It will not give you the output. What you have to do? We have to connect a auxiliary power supply to activate the transistor. Without this, you cannot make your transistor reverse bias. This zone is reverse bias zone. Na? Am I right?
Yes, sir.
So how can you make it reverse bias? By connecting that plus minus VCC. Hold on. Just hold on. So here, hello.
Yes, sir, you're audible.
Okay. Here, this is an active component because we have to make a certain part is reverse bias. Okay, as it is reverse bias, then probably it will transfer resistance will work on. That's why its name is transistors. Now, once you will make the transistor active, then you can amplify a small signal IB to a certain output voltage VL. Definitely the VL will be limited by plus VCC. Definitely VL will be limited by plus VCC, but VL কি বললো ওরা?
বললো কি যে পরে আসবে মানে আজ যখন প্রবলেম নেই যখন তাহলে পরে আসবে।
Okay. So what we have seen here, that VCC is limiting the voltage VL by 10 volt. But advantage is that I can amplify 1 microampere current by the transistor to 1 milliampere, which is not possible only by plus minus VCC. I need that component to amplify this one. The advantage of the transistor here that it can even amplify 1 microampere current to 1 milliampere current. It is huge. It is a drastic change in your electronics area domain. Once you can amplify 1 microampere current by a transistor means you can amplify any sensor output which is more than 1 microampere, but not more than 1 or 10 microampere. So a simple material which is new material in your research are able to sense some kind of physical parameter. Some kind of physical parameter might be like your emotion, might be like your body temperature, light might be like the humidity of the atmosphere, might be like the moisture of the atmosphere. Once the moisture is absorbed and a microampere level the current is developed, then how can you sense it? By a transistor you can amplify 10 milliampere. Connect a resistance of 100 or 1000 kilo ohm, you will find 1 volt. Even not with this one, you will find that 1 microampere is vary. You can find that 1 volt will be vary from 1 volt to 2 volt or 1 volt to 3 volt, which is measurable range, which is in your measurable range. Okay, earlier the 1 microampere was not in measurable range. So the materials was there, the high level sensing material was there, but you were just out of knowledge of transistor due to what? You cannot even amplify your signal from the sensors. Now once you got that amplifier like transistor or operation amplifier, you can amplify even the minimum signal to a measurable range. Not necessarily you have to amplify the 1 volt to 10 to the 6 volt. It is not your target. Your target is not like that. You have to amplify 1 volt to 10 volt. There is a transformer which can do this job. You have seen that big transformer on 30 kilovolt power line on the roadside. Have you seen?
Yes, sir.
So those transformer can amplify the voltage as well as power which will supply to a locality. But not only that, the transistor and transformer or amplifier or transformer will same function. It's not same function. It's amplifying, but amplifying your purpose different. Your purpose is amplifying the minimum change of the signal to a measurable change by a operational amplifier, by a current amplifier, by a differential amplifier. But in case of transformer, you even can transfer that small voltage signal by step up transformer or step down transformer to voltage up or voltage down, which is according to what power also will be powered up, powered down, and sufficient to supply or sufficient to enlighten your locality. But that is not been done by operational amplifier. It's a simple IC, semiconductor IC, and which one is transformer like that, which amplify 10 kilo voltage amplifier or 30 kilo voltage amplifier is purely considered in the domain of electrical engineering. And in case of operational amplifier, it is considered the domain of electronics engineering. It deals with the semiconductor physics, and this part, the earlier part, transformer part, deals with the conducting materials like metal conductor, copper, aluminum conductor. Okay, these are the two different domains. While electrical is defined and electronics is defined. Electric purpose of electrical is defined. Mainly purpose of electrical to supply the power, to supply the sufficient power to your IC, supply the sufficient power to your locality. This is the main area of the electrical engineering. Whereas in electronics engineering, the main domain is to do a control scheme, do a execution of the signal, do a perfect measurement, do a certain kind of robotics arm or robot design. Those are the considered in the electronics area. Get my point?
Yes, sir.
Okay, fine. These are the discussions of our feedback systems. Let me move on. Here you will find that the feedback topology what we discussed. Now come to the next part is Basic design of transistor. Basic design of transistor. Here I like to say you some things in my lecture or something you should remember or listen my lecture. I'll ask you questions from here. Be attentive. Huh? Very concept of any control in a system requires a measured discrepancy. Measured discrepancy means the difference between actual and desired performance. Between actual and desired performance. Okay. So it is important to have an accurate measurement system. Now I am talking about measurement systems. So a measurement systems, it is required, it is important to have an accurate measurement systems. That difference should be noted, and accurate control of any physical variable should be implemented in the operation. Okay. Like I have given an example where the temperature was expected, or the temperature was set is 80 degrees centigrade. Boiling temperature, what was set as 80 degrees centigrade, but you started your boiling by from the room temperature 25 degrees centigrade onwards, and temperature gradually increasing. Right? What you need to do, you need a sophisticated instrument to measure the perfect temperature, as well as that signal should be sent to your control room. Now, if you inserted here a manual or mercury thermometer, what happened? Let me know. What happened? You inserted a mercury thermometer. So, who will be your actuator? Who will be your measurement system here? Who will note the discrepancy between the actual and desired performance? Yellow. Put your microphone on, everyone, please.
Sir, আপনার ভয়েসটা ল্যাগ করছে।
কার ভয়েস ল্যাগ করছে?
আপনার।
সেটা বলনি কেন?
এই রিসেন্টলি স্যার লাস্ট পার্টি বললেন তো বোঝা না।
অনির্বাণ নস্কর, অঙ্কিত,
Yes, sir.
গুলশান,
Yes, sir.
রজীব, ময়না,
Yes, sir.
মুনিস, মনসুর, শিল্পা,
Yes, sir.
সৌমিক,
Yes, sir.
সৌম্যজিৎ,
ইয়েস স্যার।
শ্রীতমা,
Yes, sir.
শুভজিৎ, উদ্ভাস।
Yes, sir.
So what I have gave you that 4 out of how many students here? 15 out of 14 students are sleepy right now, are sleeping, And why you are 14 here? What about the others?
Hello, sir. Sir, there was no mic in my laptop that I could not reply you, sir. I also commented.
Okay,
You,
okay.
yes, sir.
So why you are 14 here? Sure. Jadip. Who is others here? Who is others here?
Sir, Ovidu, Anirban, yeah, Arnav and Yogesh.
So Yogesh is not here. So anyhow, Somojit, can you answer me why you are 14 here? What about the others? How many students? There is a 254 number of students in your class, right?
Yes, sir.
So what is the 30 students? 40 students.
No idea, sir.
Are they informed?
Yes, sir. So initially there was no number. I guess, sir, many are having some network issues or something like that. I don't know.
Is that true? They have an internet issue? Then how they did the
Sir, OVU point for vaccination, sir.
Huh?
So
OVU
many
point
have
for
second
vaccination.
doses now. Second dose of the vaccine.
So what happened? Second dose of vaccine. What is wrong with this one? You have the second dose of vaccine.
So they have gone. They have gone to the vaccination center.
They cannot be present in online mode due to vaccination.
Sir, they have gone to the vaccination center now. Someone just wrote in the group.
So how many of them? There are 40 number of students today.
Not 40, sir. Many are having network issues. That's why maybe. Sorry, we don't know surely.
Let me give me the why they have a network issue. Give me a proper reason why they have a network issue. So there is no tower in particular in his area, or they have no money to recharge their mobile phone. If such attendances will go on, your whole class will suffer. I mean, not by me only, by all teachers, whoever taking your classes. So this is your responsibility. Make your other friends present over here. If they have a true problem, let their problem share with me. I will try to solve from my point of from my chair. But if your attendance will be poor like that, 14 out of 54 students will be in classroom, then probably your class will suffer. Your means there will be no there will be no separations of a good student who are attending the whole classes and few students are left unattended. The whole batch will be considered is not sincere batch. So you please make your friends to be here, because it is online mode. It is not a offline mode that they have to travel to be here to attend. And one thing more, might be all teachers are not giving same way in delivery. You may have a certain kind of problem to understand, but this is not a big issue. You probably come 12 years of or 13 years of your study life, where you have seen 100 number or 100 more than 100 teachers in your life, then a few of them might be good in delivery, but rest of the teachers are not in good delivery. That does not mean that you can may have to make yourself absent in their classes, right? Get my point? It is not mandatory that all teachers should have a good delivery in the classes. All teachers obviously try to give the best delivery, but it is not to the students, or no, it's not possible for every student to understand every lecture by the teachers. If they have any kind of problem to understand the lecture, they should approach to the teachers to know this one. But if they are going to bunk the class, then it is not good for your whole class. Your whole class will be called to consider that a not good batch. not a bad, not at all a good batch. Okay, that kind of remark you don't allow to get a stick on your I mean on your glass. Try to make your friends to be here. Try to make your friends convinced to be here and let them listen the lecture. If they have a problem to understand, share their problems to me or share the problem to the class teacher. Otherwise, it might be some teacher who left your class will not take the class seriously at all. Then who are attending the class will suffer. Like here, that look, you for 14 or 15 students are right now. I am feeling less interest to take your class. I'm not be serious to take your class then. Then who will suffer? Only 14 number of students will suffer, na? So why don't you ask your friends to attend here? You should ask. They are not traveling here. They just switch on their mobile phone, will start listening, and sometimes they should answer. Anyhow, what I was discussing is that the concept here, what I said, when we are going to make a good control system, we have to definitely measure the difference or discrepancy or comparator output. That is the important one. Why? The comparator output went to the control scheme or control element. Why? The control element, in the control element, which one is the input? Error signal. This part actually most important part to get a proper or desired output. Desired output means desired in case of quantity, and quality. Quantity and quality. Desired means the output should have a sufficient good in quantity, good in quality. And quantity will be mentioned. Suppose I need 1 kilogram of rice each and every hour, then the quantity is mentioned. Now I can say I need 1 kilogram of good quality rice per hour. That means quality also displayed, right? And this can only possible by a good control scheme. That control scheme should be developed on what? Developed on error signal. Error signal means what? Error signal means the discrepancy between actual one and measure one. What is the difference between what is the error signal? Error signal is a discrepancy between actual one and measure one, right? Get my point?
Yes, sir.
So now what we can say, the accuracy of the control system, the accuracy of control systems cannot be better than the accuracy of measurement of the control variables. The accuracy of control system, then we can say the accuracy of the control system cannot be better than the accuracy of the measurement of the control systems, control variables. Get my point? Can someone say what I said? Can someone say what I said?
Sir, the accuracy of the control system cannot be greater than the accuracy of the control variable.
Right, accuracy of control. So measurement is so important ever to get accurate control systems that we have to get the all fundamental idea of the measurement of the system. Look, one thing more important over here. When you will be in final year, you probably sitting for some job in interview for software company, right? It might be suppose CTS, it might be TCS, it might be Oracle, it might be Microsoft, even Google. The people come for the interview might have a background from instrumentation or electrical or electronics or mechanical even, or some people come from computer science. The interviewer so interviewer will ask some questions to the student of instrumentation, definitely some fundamental questions from the instrumentation. If the students can answer them satisfactorily, then they will ask some questions to know his or her knowledge in computer science or in programming. If the student have no knowledge in their own departmental subject, the interview will not ask any question from the computer science for the recruitment. So it is very important task for you to know the fundamental of instrument to get a job in software world also. Because if you don't have any fundamental idea of instrumentation, then probably you have an idea in engineering which you are studying. Then how can you do a job in other field? Right? So they will be confused and they don't like any confusion. So they will reject you. So this part is important. The fundamental part of instrumentation is here. The accuracy of control system cannot be better than our accuracy of measurement of control variables. So the more modern sophisticated instrumentation, modern sophisticated instrument systems like autopilot, automatic landing of aircraft, missile guidance, radar tracking systems, whatever we are going to know, we'll find there will be certain physical parameters or certain parameter which require to be maintained properly. Not only maintained properly, as well as control them properly. So automatic control schemes are widely used. Okay, the automatic control scheme is widely used in those sophisticated systems as well as some general systems like oil refinery, chemical plant, textile mills, papers mill, etc. etc. Okay, the simulation of the system condition. This is another important parameter which you for what goal you will be taken in software world. What I said, the simulation of system condition. Simulation of system condition means this part we can say simulation of what I said. System condition. Simulation of system conditions. পড়তে অসুবিধা হচ্ছে না তো?
No, sir.
না স্যার জাস্ট যখন কিছু পয়েন্ট আউট করবেন একটু বড় কোনো পয়েন্টার ইউজ করবেন, ওর পয়েন্টারটা এত ছোট বোঝা যাচ্ছে না।
মোবাইলে করছো তাই?
হ্যাঁ এটা ঠিক।
তাই তো?
হ্যাঁ স্যার।
আরে এইখানটাও তো মোটা হওয়ার একটা লেভেল আছে, তার বেশি হবে না তো। ধরো আমি এইখানটায় এর বেশি তো আমি পাবো না। হ্যাঁ এইটা আমি করছি, এটা মোবাইলে করলে তো এইটাই হবে।
হ্যাঁ
চেষ্টা করো ক্লাসগুলোকে যদি সিনসিয়ারলি করো তো এতে করার চেষ্টা করো, ল্যাপটপে বা কম্পিউটারে করার চেষ্টা করো। পারলে টিভির পেছনে ওই সিপিইউ লাগিয়ে দেবে। এখনকার তো স্মার্ট টিভি, আরো যত বড় স্ক্রিন হবে তত বড় ভাবে দেখা যাবে এবং তত তুমি ফোকাস থাকবে। মোবাইলে করলে ঘুম পেয়ে যাবে। So what I said here, simulation of
system condition.
Look, today you probably hearing some words from your senior. কতজন চাকরি পেলে, they said that out of 50 or out of 60 or 20 number of seniors already got job in TCS, or 40 number of students got job in Oracle. No, can you make it clear why the computer science world are taking students from instrumentation? Do they better perform than a computer science students? Do you feel for this reason they are taking? What is the reason?
স্যার কোম্পানিগুলো যেটা ডিজায়ার্ড সেই জিনিসটা এদের মধ্যে পেয়েছে, অন্য ডিপার্টমেন্ট থেকে হলো।
The reason they are taking that, they need some expert from the instrumentation to help the software development. To help the software development. How the software development will be helped by instrumentation engineer? Because they have a good idea of the system conditions. They have a good idea of the system condition of a plant like oil refinery or like a sophisticated plant, radar tracking systems or missile guiding. Okay, this kind of control system is not studied in computer science engineering. They might know the programming, but they have no idea about the true engineering process. So a system condition, suppose we need a software to develop for automation in oil refinery plant. Okay, then somebody required to explain what is oil refinery plant. Then after the software engineer will start designing what are the important parameters, how the set value will be considered, how the control scheme is required, what is the control scheme. Should be there a person who will explain that particular domain. Then the programming will be done. Okay, so who will explain that part? Instrumentation engineer. So they need computer science students from computer science background, as well as they need students from instrumentation or electrical or production background, because they actually work in various field of engineering. বুঝেছো?
Yes, sir.
Yes, sir.
Now, no, what is system condition? System condition is that it will be better to say that it is necessary, the simulation of system condition is necessary to simulate experimentally the actual condition of the complex situation. Actual condition of complex situation for revealing the true behavior of the system, for revealing the true behavior of the system under different governing conditions. Okay, under different governing conditions. This is the main requirement or necessary of the simulation of system condition. This is primary, first one. Second one is experimental design studies. Second one is experimental design studies. So once you understand the system condition and simulate it in a software world, then the experimental design will study. Experimental design means what? Experimental design means it can be said that design and development of a new product which involves in trial and error process, which generally involve in to use the empirical relation. What I said? Design development of a new product. Like earlier picture for feedback control system, we said that there will be raw material input or energy input. If the material is raw, then definitely the product will be something new. And suppose the material is crude oil, or suppose the material is here naphtha. Naphtha means a product from crude oil. From the naphtha, the different kind of polythene or the materials are come out. Some is transparent materials which are used to design the Bisleri bottle or Inlay bottle, whatever. This is particular kind of aliphatic materials, and some materials there are also which are used to design syntax tank, overhead tank, domestic tank. You have seen no in your house probably domestic tank is the overhead tank, syntax tank cost almost 10,000 rupees and 1,000 milliliter tank. Okay, these two product actually come out from what? Naphtha. Naphtha is the basic mother materials, and from that the two materials are extracted. Now that particular design and development of a new product generally involves in trials and error process. Trial and error process means what? Suppose there will be certain kind of error, then that error will be minimized. Again, you make a trial. You will find the new error that might be less, but new error. What you have to do? You have to take another step to control the design. Okay, this way, one way you finally can get your final product. Okay, so that trial and error process which generally involves the use of empirical relation. Empirical relation, definitely there will be relations which actually help us to run the process in trial and error method. Okay, so handbook data, the standard practice mentioned in design codes have to report to experimental design studies for supplemental design and development of the work. So you will find there will be certain kind of standard handbook. Like I said, syntax tank, the dimension of syntax tank, the material quantity, particular combination of others materials. These are given over the specific scientific specific books, handbooks. Okay, depending on the empirical relations are developed. And these relations again they help to develop to new product. Okay. Now next point is the performance of various manipulation. Performance or to perform various manipulations. স্পেলিংটা ঠিক লিখলাম তো? হ্যাঁ, স্পেলিংটা ঠিক লিখেছি?
MAN
হ্যাঁ স্যার।
আচ্ছা ঠিক আছে।
So what I want to mean by this one? In a number of cases, the instruments are employed to perform operation. What kind of operation? Like earlier in our operational amplifier, we have seen that there will be certain kind of mathematical operation. Okay, mathematical operation means additions or subtractions. Even using op-amp, we can do a integration or differentiations, logarithmic, anti-logarithmic. Probably I said this one last day. Okay, this kind of operation can be done by the instrument or instrumental components or part of instruments. Okay, so these mathematical operations like addition, subtraction, divisions, integrations, etc., or some kind of ratio control, feedback control, cascade control. These are also some kind of control where the parameter will be considered, can be done by that instrument. In certain cases, the instruments are also used to determine the solution of the complex differential equation. In certain cases, the instruments are also used to determine the solution of certain differential equations. or other mathematical manipulations. This is also important part to perform various manipulations. That is also a part of the instrument. Okay. And next part is testing of material, maintenance. स्पेलिंग টা দেখবে maintenance ঠিক আছে তো of standard standards and specification of products. Testing of materials, maintenance of the standard and specification of the products. This is another important. What I am explaining here, 1, 2, 3, 4 is actually the whole engineering you are studying and whole engineering environment where you will work on. The testing of materials when the material come out. As I said, the quantity and quality is the main aspect. The material quality is important. Quality assurance is important. Okay. Suppose we are going to produce a naphtha, like you are quite familiar with this phenomena. Suppose few people prefer Bharat petroleum to fill their tank of car. Few people prefer IOCL. Few people prefer Castrol 40X to fill the engine oil of their bike, or few people prefer servo. Servo. Do you know what is servo? What is mobile?
So the oil to lubricate the engine parts, like the gears and things.
They both are lubricant oil. Coming out from the crude oil, but manufacturers are different. One is IOCL, that is servo. One is Bharat Petroleum, who named it mobile. Right? This is probably mobile, and one is called Castrol. That is Hindustan Petroleum give it Castrol. They all are coming out from the crude oils, and all are basically lubricant oil or lube oil. That lube oil actually make our engine smoother in operations. Now look, the servo or Castrol or mobile, both are maybe same in their chemical compositions, but their performance is different. Why the performance different? Different because their quality is different. They may be extracted in a certain temperature, which is best for the particular engine, like Castrol 40X. Normally, your R5 or new bikes, that very sports bike type bikes today are available, RZ5 or whatever. Those kind of bikes actually good. The engines are very good with the Castrol 40 GTX. Whereas earlier the two-stroke engine like Rajdut, Yamaha, even Bullet, they are actually work on the Castrol 2T. So that two type of same Louisville perform different because of what? The material quality. So the testing of the material is important, and according to what it will be commercially sellable. Same time, the maintenance of the standard and specification. Suppose Maruti Udyog company, Maruti car company are selling Baleno, and Baleno quality is good. They remember this once and keep that specification standard for long time same. As if the car who are using the Baleno will be satisfied for long time. Same thing happens for what? Like ambassador. This is the I mean, mostly most popular car in India since 1947 or 37, like that. It was first in branded like Morris company. Then its name in India is Ambassador. Hindustan Lever was producing that Ambassador, and the quality and standard of the Ambassador preserved or maintained for more than 40 years, 50 years. And nobody that time questions the quality standard of the ambassador car. It was very good. Not only good, it is very safe respect to the even today's modern car. Might be today's modern car having some kind of airbag or some kind of, but the body of the recent car are not strong enough like ambassador. Okay. But the comfort, if you talk about the comfort level, definitely in case of comfort level, the standard was not maintained properly of the ambassador. Due to what? Due to only what the ambassador is obsolete or he actually stopped producing their car. Okay. So the maintenance of the standard specification of the product as well as testing of material is very important to sustain in the market, competitive market. To sustain the competitive market. Okay. Now that verification and physical phenomena, verification of physical phenomena and scientific theory. These are the also important part of the engineer used to execute in instrumentation world, which quite often experimental data is generated to verify a certain physical phenomena. Okay. It is quite often that experimental data is generated to verify a certain physical phenomena, like Coulomb. Coulomb postulated that the frictions between two dry surfaces is proportional to the normal reaction and is independent of the area of the contact. So what I said, Coulomb postulated that the frictions between two dry surface is proportional to the normal reaction and is independent of the area of contact. His hypothesis has since been verified experimentally and is now known as Coulomb's law of friction. Sometimes it is called Coulomb's law of dry frictions. In fact, such example, okay, in fact, such example are numerous in the field of engines. Whenever a scientist or an engineer progress any hypothesis predicting the system's behavior, it need to be checked experimentally. It needs to be checked experimentally to put the same on a sound, on a effective posting. Okay. So after that there will be, so what I said, the fifth point, verification of physical phenomena or scientific theory. scientific theory. And next point is quality control in industry. The next point is quality control of industry. It is quite common this day to have a continuous quality control test of a mass produced industrial product. Okay, the effective components that are outright rejected at early stage of the productions will actually helps. Effective product means what? Not effective, ineffective product gulo, ineffective product or defective product. Okay, that should be outright or rejected at the early stage of the production. Then we will find the good quality product as it come out of the process. As it come out of the outcome of the process. Okay, and quality control, it's so important that in engineering quality control separately considered as branch of engineering. And there is a famous person in service engineer is a quality control engineer or quality assuring engineer. In even mechanical, in even electrical, that quality control, in even production engineering, quality control are very important subject to be studied. Okay. And anyhow, these are the most important points. These are the most important points in instrumentation. As an engineer, you have to work on. Now, the functional elements of the measurement systems. I'll come to that point. Is functional element. Okay. Generally, what I am discussing now, measurement systems. Why I am discussing measurement system? Because we seen that in instrumentation there will be a control scheme, and that control scheme actually deals with what? Deals with what? Give me a break. So whatever I said, is it understandable?
Yes, sir.
Can you remember them? I hope so. Anyhow, now come to the next part. This is actually functional elements of a measuring systems of a of a measurement system. সোজাই হলো না। So what is the functional element of a measurement systems? It may consist of two systems. One is basic functional elements and second one is auxiliary functional element. One is basic functional element and two is auxiliary functional element. Okay. Now what is basic functional element? Basic functional element basic functional element is one transducer or transducing element, transducer or transducing element. One. Number two, signal conditioning element. Conditioning element. Condition মান কি ও কি আইবেন তো ঠিক আছে
আচ্ছা ঠিক আছে
conditioning element. And number three, the data presentation element. What is transducing element? Transducing element means which sends and converts the desired input to a more convenient and practical form to be handled by the measurement systems. What I said? It converts desired input signal or desired input to a more convenient and practical form. More convenient
So the transducer in secondary elements and this transducer is same.
I'm coming to that point. Transducer in secondary element means?
So there was a transducer in the secondary element, right?
No, I am talking about the functional elements. Last day, have I said all those things?
So in the first class, you said about primary and secondary instruments, and in secondary instruments, there was a transducer, sir.
These are the classification. What I said in that case,
sir.
This is the classification of transducer. What I have started now, I have considered the instrumentation system. Now I am considering a basic instrument. So in the basic instruments, it's what I am talking about is construction. Okay. What I am talking about the construction, and earlier what I said is a classification. Classification means they are classified like a primary transducer or secondary transducer. Primary transducer directly measure the inputs, okay, design inputs, and make it convenient, more practical output. Okay, this is the primary one. But when we need to make that output of the sensing part to another sensor to fit to another system or transducing element to make more convenient or practical, output, then it will be called secondary. The first one will be the another transducer, second one is the intermediate transducer, and then after we will get the output. Okay, so I'm talking about the data construction in details right now. Okay, other what I said is a classification. Okay.
Yes, sir. Yes, sir.
So my handwriting too bad. I think it's very bad to understand, and still I'm writing whatever I am writing over the graphic pen. It's horrible to understand right now, even for your visibility also. Let me. I cannot make it good right now. Okay. So probably
It's okay, sir. We can understand, sir.
Okay, very good then. Thank you for your cooperation. Now, what I want to say here that the transducer element which converts the desired input to a more convenient practical output. Okay. And the next part is a signal conditioning element. Signal conditioning element, as I said, in the primary signal systems or primary systems, after primary sensor, there will be certain part which is consist of some electronic component. Okay, to do some mathematical operation like logarithm amplifier. Yesterday I discussed about the multiplier, divide, how a divider is designed by electronics component, right? How a integrator will be designed. Similarly, that time also important thing is the filter. Probably you studied the RC filter, passive filter. You will find some filter over here also in electronics. Water filter, Chebyshev filter, notch filter. Those filter also designed by electronics component like operational amplifier, resistance, and capacitors. But filter required to be stable and very efficient, should be very efficient to remove the noises from the electronic circuit and produce noise-free output for our better understanding, for our accurate understanding. What do we know? The accuracy of the control systems is not better than our accuracy of the measurement. So we have to make the system more accurate, then we will able to get the more accurate control systems. Like sophisticated instrument, where the missile guiding is important, where the Mongolian are developing. So most accurate control system demands more accurate measurement. And more accurate measurements means there will be noise-free output or noise-free signal. And noise-free signal is not is possible? No, it is not possible. There should be noise. But noise-free method should be most accurate, as if it can reduce the noise to a very minimum level, as if it will not influence the whole control system. So where you will find that, where you will install that based electronic mathematical operation, signal free processing operations, where you will install all those part, signal amplification part, attenuation part, where you will put, it will be put in signal conditioning element or intermediate modifying elements or intermediate modifying elements. Or intermediate modifying element. So what are the main inputs here? That, as I said, the mathematical operations, some electronics operations, some filter, signal processing operations, signal amplification, attenuation, conversion options will be here. And last one is the data presentation part. Data presentation means what? It can be executed. It can be executed through a display. It can be recorded or it can be stored in memory chips. Okay. Now come to the next part is auxiliary part. auxiliary functional element. Auxiliary functional element means what? Auxiliary functioning element here which incorporated in a particular system depending on the type of requirement. Depending on the type of requirement, nature of the measurement techniques, like calibration element. Look up table, rather will find that certain kind of calibration element, automatic calibrator will be in some instrument which is a auxiliary element. It is not a primary element at all. It's an auxiliary element. Okay, you probably handle the DSO. You will find there auto calibrator. Once you push the auto calibrator, the whole skin will be calibrated as if that whole noise or whole signal measurement can be done in a particular single skin. You don't need to zoom in or zoom out the whole signals. Auto calibration will make this one. Okay, so this is auxiliary part. Similarly, another part is external power element. External power element. Some instrument require external power supply, like battery. Okay, in case of computer, what do we need? We need a UPS, external power supply. So UPS will be just kept out of our system, but it is important for our system to make a continuous output for betterment of the instruments or for safety of the instruments. Okay, so the external power element also facilitates the working one or more elements like a transducer element or signal conditioning element or data processing elements or even feedback elements. So it can serve most of the elements as a auxiliary power supply. Third point is a feedback element. Feedback element means which one? The multi-cyclic, certain kind of feeding back the input, output to inputs. Okay, this is sometimes is a auxiliary part, and you will find in different kind of instruments, like in your in your stability of the transistor. You will find that there will be two R1, R2 are connected in a base with the emitter as well as collector, which actually feedback system to get the stability, to increase the stability of this transistor, as if the thermal runaway should not be happen. Studied, no? The term thermal runaway, have you studied? Are you there?
Sir, we have not studied, sir.
থার্মাল রানওয়ে পড়োনি তোমরা? কি তোমরা কিন্তু খুব ফাঁকি মেরেছো। আমি মানে ও তোমরা তো 2020 ব্যাচ না? আচ্ছা আচ্ছা, সরি, তোমরা তো পড়োনি কিছু, তোমরা তো টুকেছো। সরি সরি সরি, তোমাদের কাছ থেকে আউটপুট পাওয়া যাবে না। খুব বাজে লাগছে না তো, এইটা তোমাদের হয়তো দোষ নয়, কিছুটা তোমাদের দোষ, কিছুটা নয়, কিছুটা সিচুয়েশন তৈরি করলো। কিন্তু এই জিনিসগুলো তুমি যেরকম তোমরা চুপ করে আছো না, এটা না আমি 16 বছরে কোনোদিন যাদবপুরে কোনো স্টুডেন্ট এই ব্যাপারগুলো চুপ করে থাকে, তারা বলে এগুলো কি স্যার, এগুলো বলেননি কেন, এগুলো জানি না কেন, বা তারা বলে স্যার থার্মাল রানওয়ে জানি, তারপর একটা বলুন, এরকম বলে। আমি 16 বছর পর এত ডিটেলসে বলতে হচ্ছে আর কি। না, এটা দুর্ভাগ্যজনক আমার কাছে, তোমাদের পক্ষেও দুর্ভাগ্যজনক, যেহেতু তোমরা এইরকম ক্লাস মোডে পড়োনি বা পরীক্ষার জন্য নিজেরা পড়ে পরীক্ষা দাওনি। কিন্তু এগুলো বেসিক কোশ্চেন বাবা, উইদাউট নোয়িং দিস ওয়ান ইউ ক্যানট গেট এ জব। ইনফ্যাক্ট আমি যদি ইন্টারভিউয়ার হই, আমি তো নেবো না। আমার যতজন বন্ধু তারা যদি ইন্টারভিউ নিতে আসে, তারা তোমাদের নেবে না উইদাউট নোয়িং দিস ওয়ান। থার্মাল রানওয়ে জানো না, হাউ ক্যান ইউ বি ইঞ্জিনিয়ার অফ ইলেকট্রনিক ফিল্ড? That is a big question, sir. How can it be an engineer knowing no thermal runaway or knowing no concept of transistors? Anyhow, thermal there will be stability to how the thermal actually in case of transistor there is a magnetic carrier flow. Okay, magnetic carrier flow you cannot stop it, but sometimes the magnetic carrier flow through a resistance produce huge heat energy. In reverse bias, resistance is huge, so H equal to I square RT. So magnetic carrier might be there, but R is there, R is huge. So heat is produced by the transistor, and that heat is so much high that it itself burns the transistors. Okay, this is called thermal runout. So what we used to do, we have to connect a resistance from collector to base and base to emitter, as if that excess current should be drained out directly to the ground. Okay, drain out directly to the ground. Okay, this part is called feedback part. To make the transistor stable, it should not be thermal runaway conditions. So this is feedback element, like example of a transistor component. You will find several instrument we having a feedback element to make it stable in temperature variations or magnetic field variation or electric field variations. And fourth one is a microprocessor. Now today everything is smart, like your mobile phone. Earlier mobile phone was enough to communicate with the 1:1. Okay, now the mobile phone is so smart that not only it even able to communicate 1:1, it sometimes make a conference for, even through mobile phone with the internet, you even can communicate more than 100 peoples at a time. Like right now I am doing. I'm not doing through the mobile phone, but we can do that communications by mobile phone. So it is possible for what? It is possible due to the microprocessor and microcontroller. Microcontroller means microcomputer. Microcontroller means a microcomputer. Mobile phone is like a microcomputer today. Is a small computer today, and it can do every kind of works by a mobile phone. But this is not a mandatory requirement of the mobile phone. Basic mobile phone is a one-way communications, and that is a duplex. Sorry, that is a duplex communication, and that communication done by Nokia 3310 or 108 or some earlier devices. But today, whatever you have in the Android phone is a someone smart enough, and it has different OS. Yes, this very smart microprocessor, RAM, etc., 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 which was not a primary one but auxiliary one. Okay, is it clear?
So what is the difference between microprocessor and microcontroller?
A microcontroller is a simple microcomputer. Okay, a computer, you know, there is a CPU, processing unit, as well as processor. Except this one, what you have in a computer? RAM, ROM, CD drive,
Storage device.
input
It's arithmetic logical unit, ALU.
Arithmetic logic unit. I am coming to that point later on. First, what do you know about the computer? You know that there will be a CPU or processing unit, and in processing unit you will find there will be a processor, and additionally you connected with the processor with the RAM. Okay, a hard disk, a ROM, a RAM and ROM, and also you know that there will be certain kind of input output device like CD writer or like monitor output device. Okay, like keyboard input device. Using this one you can run a systems. In processing unit processor, there will be certain part is a arithmetic logic unit, which one is works on arithmetic operation, which actually works arithmetic operations and logical operations. So that's why it is called arithmetic logical unit. And some part is called registers. Some part is called registers, mean memory, small memory elements, flip-flop type memory elements or small register. Registers means some 8-bit memory element which holds some data for few fraction of time for execute the logic. To execute the logic. Okay, and except this one, the processor. This is the whole thing of the processor, and out of the processor there will be certain memory device as well as hard disk or RAM, and as well as some input output device. Microprocessor is a simple same thing. It's a processing unit, but without having any kind of permanent RAM or permanent ROM type devices. RAM is not permanent memory, but permanent RAM means there will be no RAM or ROM inside the microprocessor. There will be few register and arithmetic logic unit. You would depending you have to interface that processing unit with some RAM and ROM. Then the OS will be stored in ROM. According to OS, you can run the program, and at the time of running a program, the RAM will be used. And finally, you have to connect the processor with the output device like monitor. You have to connect a input device like keyboard, through what you will give your input to the processor. And after the running of the program will be displayed by the display. I mean, output device like monitor. Okay. then it will be considered a computer. What is a microcontroller? Microcontroller is a small IC, embedded IC. Inside of what there will be a RAM, small RAM. Its RAM size is 128 byte RAM. 128 byte RAM. An 8-bit microcontroller is called 8051 Intel made 8051 8-bit microcontroller. Inside what you will find a 4 kilo ROM and 128 byte RAM. But Intel made 8085 8-bit microprocessor only have certain kind of 8 register pair and arithmetic logic unit. Nothing more of this. What you have to do? You have to connect some input device, interfacing device to connect the keyboards as well as display to run the program. That is the difference between microprocessor and microcontroller. When you study this subject, you will understand in details. Okay. So this is auxiliary element what I said, and finally I said about the
Microcontroller.
okay, microcontroller. So come to some description of an instrument. Like yesterday I have shown you a instrument is a button gauge. Am I right? Button gauge. Let me take some picture from internet.
You see the drip that I fitted up. I'm in my car and the giddy up. Secure the bag, yeah, I get the bus. I'm in my car and the giddy up. Secure the bag, yeah, I get the bus.
The operating pressure in hydraulic or pneumatic systems is measured with respect to atmospheric.
Just see the picture of the instrument.
The most common pressure gauge. The operating pressure in hydraulic or pneumatic systems is measured with respect to atmospheric pressure by pressure gauge. The most common pressure gauge design. Design was contrived by Eugene Bourdon. It used a curved tube design as the pressure sensing element.
Is it okay?
Pressure gauge with Bourdon tube contains case, socket, Bourdon tube, plate, mechanism, dial with scale, pointer, window,
I'm stopping
ring.
my microphone. If the sound is clear,
The
let me know.
pressure gauge housing is most often made of stainless steel or plastic. The operating pressure in hydraulic or pneumatic systems is measured with respect to atmospheric pressure by pressure gauge. The most common pressure gauge design was contrived by Eugene Bourdon. It used a curved tube design as the pressure sensing element. Pressure gauge with Bourdon tube contains case, socket, Bourdon tube, plate, mechanism, dial with scale, pointer, window, ring. The pressure gauge housing is most often made of stainless steel or plastic. Board and tube is made of copper, brass or bronze. The pressure difference between the pressure in the system and atmospheric pressure causes the free end of the board and tube to deflect accordingly. Movement is transferred via the mechanism to the pointer. At this moment, the pressure decreases and the board and tube returns to its first position. The accuracy class for pressure gauges is expressed as a percentage of the span. For example, class 0.6 is class for pressure gauges with absolute accuracy better than 0.6% of the nominal full-scale reading. The readings of these gauges are slightly different. It's normal. These pressure gauges have different accuracy classes. With respect to atmospheric pressure by pressure gauge. The most common pressure gauge design was contrived by Eugene Bourdon. It used a curved tube design as the pressure sensing element. Pressure gauge with board and tube contains case, socket, board and tube, plate, mechanism, dial with scale, pointer, window, ring. The pressure gauge housing is most often made of stainless steel or plastic. Board and tube is made of copper, brass or bronze. The pressure difference between the pressure in the system and atmospheric pressure causes the free end of the board and tube to deflect accordingly. Movement is transferred via the mechanism to the pointer. At this moment, the pressure decreases and the board and tube returns to its first position. The accuracy class for pressure gauges is expressed as a percentage of the span. For example, class 0.6 is class for pressure gauges with absolute accuracy better than 0.6% of the nominal full-scale reading. The readings of these gauges are slightly different. It's normal. These pressure gauges have different accuracy classes.
Sir, your mic is muted, sir.
Okay, thank you. What do you understand from the picture? Look, that is the one pictures I just copied from a books. Okay. So this is button gauge. Can you hear me now?
Yes, sir.
So this is button gauge, and how it works, you have seen. It expands, and according what the movement happens. Now look, here is a certain tips. The tips, our pointer connected here with the Lvdt structure. Lvdt structure. So Lvdt means, do you have any idea of Lvdt? Do you have any idea of transformer? Have you studied in basic electrical measurements? Transformer?
Yes, sir. Only step up and step down transformer.
No. I just want to know that whether you have attempted any questions from transformer in your last assignment mode examination.
The operator.
Huh?
No, sir.
Okay, I am showing you another video for quick understanding of Lvdt, but don't need to know it details. I will discuss, definitely I will discuss in details in future also. If you can remember these things, it's good. Let me show you a animation of Lvdt.
Good grammar and spelling are important.
LVDT is also known as Linear Variable Differential Transducer or Transformer. It is a passive transducer which measures displacement. It consists of a primary coil wounded on a hollow cylindrical rod and is connected to the AC source. It also consists of two secondary coils having equal number of turns and is wounded on a hollow cylinder at equal distance on either side of the primary coil. The two secondary coils are connected with each other in series opposition, so that the net induced EMF of the two secondary coils becomes, we see that a movable soft iron core is placed inside a hollow cylinder. Position of this core with respect to the two secondary coils will affect the magnetic coupling between the primary and two secondary coils. Let's now understand how this LVDT works. We see that when an AC source is activated, alternating current starts flowing through the coil, due to which varying magnetic field is produced. Now, when this varying magnetic field interacts with the secondary coil, an EMF is induced in the two secondary coils. We see that initially the core is placed in such a position that equal EMF gets induced in both the coils, due to which the net EMF of the two secondary coils becomes zero. This position of the core is known as null position. Now, if we move the core towards the right, we see that the flux linking with coil S2 becomes greater than the flux linking with coil S1. As a result, the EMF induced in the coil S2 becomes greater than the EMF induced in coil S1, and the net EMF shows a negative value. Similarly, if we move the core towards the left, we see that the flux linking with coil S1 becomes greater than the flux linking with coil S2. As a result, EMF induced in coil S1 becomes greater than the EMF induced in coil S2, and the net EMF shows a positive value. Thus, LVDT uses the magnitude and polarity of the net EMF induced to measure the displacement of its core from the null position.
Have you seen this space-age roofing product that lowers energy bills without solar panels or batteries? This previously unknown product will soon be available across the United States.
Lvdt. Lvdt is also known as linear variable differential transducer or transformer. It is a passive transducer which measures displacement. It consists of a primary coil wounded on a hollow cylindrical rod and is connected to the AC source.
Hello guys, this is Siddharth Saratkar and I'm back with another interesting stuff of electronics, that is LVDT. So without wasting much of yours and my time, let's begin with transformer, or can say linear variable displacement transformers. These types of electrical transformers are used in measurement of displacement. These transducers are pretty cool and this is used in a large variant in electronics world. Let's talk about the construction part. It consists of a primary winding which has been provided with an AC source, which is considered as an input here. Further, the primary winding is done on a hollow cylinder. It consists of two secondary coils of equal number of turns which is kept apart from primary coil with an equal distance. These two coils are connected in series connection, and at last comes the hero of the whole movie, or you can see the whole video. That is the core part, which is kept inside the hollow cylinder. Now let's jump to the section of working of LVDT. As when we switch on the AC current, a varying alternating current is flowed on the primary coil, due to which varying magnetic field is produced. And when a varying field interacts with the two secondary coils kept there, an EMF or electromotive force is generated. An output signal can be recovered from that thing. On analyzing the diagram, we see that the core is kept in the middle of the setup, which results in equal EMF, and that comes out to be 0. But when we move the core towards coil number 1, the EMF across the coil increases, and the same thing repeats in the case of second coil. There would be one difference, that EMF would be negative, while in earlier case it was positive. As the expression says there, E is equals to E1 minus E2. And I hope now it would be easy for you to relate. Further, it uses two factors, that concludes magnitude, and the second one is polarity. Here the polarity can be related to a phase shift of 180 degree to reach a particular output. Now let's come to the question why. Why should we use LVDT? After asking question, we come across answers like it is an absolute position sensor, as even if the power is switched off, on restarting it, LVDT shows the same measurement. According to the important properties of transducer as shown in my previous video, it has a great repeatability and reproducibility once it is properly configured. LVDT produces continuous resolution and shows a low hysteresis curve. If you are not aware about the properties which
spezifisch konfektioniert. LVDT bedeutet linear variabler, lässt sich eine theoretisch unbegrenzte Auflösung erreichen. LVDT-Ventilsensoren können selbst kleinste Positionsänderungen der Stößel messen. Die Ausführungen von Inelta, die für Messbereiche von 1,2 mm auch als Ventilsensoren für Hydrauliksysteme an, in großen Stückzahlen und kundenspezifisch konfektioniert. Linear variabler. Mit diesem induktiven Weg lässt sich eine theoretisch unbegrenzte Auflösung erreichen. LVDT-Ventilsensoren können selbst kleinste Positionsänderungen der Stößel messen. Die Ausführungen von Inelta, die für Messbereiche von 1,2 mm bis 10 mm erhältlich sind, ermöglichen eine Ventilpositionierung im Mikrometerbereich. LVDT-Sensoren bestehen aus einem hohlen Spulenkörper mit einer Primär- und zwei hintereinander liegenden Sekundärwickelungen, in dem sich ein Kern aus einer hochpermeablen Eisen-Nickel-Legierung kontaktfrei in axialer Richtung bewegen lässt. Je nach Position induziert der Kern unterschiedliche Spannungen in den Sekundärwickelungen. Die Differenz der gemessenen Spannungen an den beiden Sekundärwickelungen wird in ein analoges Normsignal transformiert, das die Wegänderung des Kerns in linearem Verhältnis abbildet. Das Ausgangssignal kann entweder für die präzise Steuerung eines Proportionalventils oder als Schaltsignal
Sir, mic is off, sir.
Am I audible now?
স্যার লাস্টের ভিডিওটা এক্সপ্লেন করতে পারবেন? ওই ল্যাঙ্গুয়েজের জন্য বুঝতে পারলাম না।
ওই একই জিনিস দেখিয়েছে, that actually same thing, two coils, that coil 1, that is coil 1, and that is coil 2. These two are secondary coil. Secondary coil. And this one is a primary coil. Primary coil. Look, if in primary coil, if a transformer I design this way, and this will be another secondary transformer, we are keeping them apart. They are not connected physically. There is a air gap. Okay, there is a small air gap. Now this is primary one. Why? I have supplying a current to this one is the IP, and this is inductance LP. Definitely there will be a resistance RP. These are the primary side. Current is IP, resistance is RP, and inductance LP. So across inductance there will be EMF. I mean, there will be a voltage, right? And as you know, the electromagnet means what? When through a copper coil current flows, a magnetic field created, right? Lenz's law you studied, na? In 12, class 12. Why?
Yes, sir. Yes.
This part have you studied? Lenz's law?
Yes, sir. We have studied Lenz's law, sir.
We have studied Lenz.
So in Lenz's law, you will know that through a magnetic, through a coil means conductive coils, electron when flows, then one electron try to induce the other electron through a magnetic field to stop flowing. This is called inductance. Okay, when this coil keep close to another coil, they might be not conducted, but that magnetic field actually force a electron to force the free electron of the conduction band of the conductor will force the free electron of the conductor to flow from this point to this point. That means electron will start flowing. Due to what? Due to the magnetic field created by the primary coil. That is called induced EMF. That is called, induced or mutual inductance. That is called mutual inductance. Mutual inductance. That mutual inductance actually induces the secondary coil. So due to a magnetic field, a copper coils in a turn position, so a electron will start flowing to the copper coil immediately when the magnetic field induces the secondary coil. Okay, so this electron actually is the reason, this flow of electron actually reason of the secondary current. So we will find here a current IS, that is secondary current, and this coil is having a inductance LS, secondary inductance. Definitely there will be resistance RS secondary resistance. So that current IS actually across the RS will produce a VS secondary voltage. That current IS which is produced due to the mutual inductance from the primary coil to the secondary coil due to the current IP actually produce another current IS. Okay. So what I said, the IP the IP actually main reason to produce mutual inductance MI. Okay, due to what secondary coil will find a IS secondary current, this one, and that IS passing through what RS secondary resistance, so you will give you a ES secondary voltage. So here is the two coil, so that two coil will give you ES1 and ES2. Okay, now the thing is that, is it visible?
Yes, sir.
Okay. So here what I drawn a picture, primary coil, a secondary coil. This is primary coil LP. This is secondary coil LS. Right? What I said, they are keeping apart. That means what is between them? Air. What is between them? Air. So if it is magnetized due to IP, if it is magnetized, then the current might be flowing this direction, or line of flow or line of force will travel this way. Line of force travel this way and induce this one. Okay. So this electromagnet magnetize this one, or this inductance will induce the inductance. Okay. To a magnetic field. Okay. Is it clear?
Yes, sir. Yes, sir.
Now, if we keep that coil far away, then the magnetic field will be less here, right?
Yes, sir.
Then tell me when the IS will increase. When, which situation IS will be increased? The secondary coil current, in which situation it will increase?
So when it is closest to that coil.
When it is closest to the coil. Why?
So maximum change of electromagnetic force and force lines will be present, and maximum current will be produced.
Right, in
maximum flux linkage.
Line of force. Maximum line of force travels this way. Okay. And induce the coil. More line of flux will pass through the coil, means more induction. Okay. And another method we can do to increase the current, IS. How we can increase the current here? Except this one, keeping them close.
So introducing a core.
Introduce another magnetic core. Right. Excellent. Very good. This is excellent answer. So a core or iron, if we put between two magnet, I mean this is magnet, a iron core here, the iron core behave like a magnet and induce it, right? So that means the induction will increase. If we put a iron core here, it will behave like a temporary magnet. So what actually it reduce? Reluctance. The term is here reluctance. What I say? Like resistance, it is reluctance. Reluctance means a property of the medium which resists the line of flux or line of force to pass through. Okay. So if we place a iron core between the two primary coil, the secondary coil, then induced current will increase. If coil is not here, then induced current will be less. So one position you consider, coil is not here. The current is 1. And next position you consider iron core placed between two coils. Then the current is 2. Now tell me is1 greater than is2, is1 less than is2, is1 less equal is2, or is1 never related with is2. Which one will be true?
Sir, could you repeat the question once?
Yes,
There
sir,
is a
just
two
repeat.
coil. There is a two coil, primary coil and secondary coil. They are kept in a fixed distance. Okay. Now the current induced the secondary coil IP induce the secondary coil produce IS1. Okay. When there is a no core, I mean as they are kept in a same distance at a fixed distance and no core is there, no iron core is there. So then the current is IS1. Now we place iron core between them and we measure the current. This is the IS2. Now what is the right answer? IS1 will be equal to IS2. IS1 is greater than IS2 or IS1 is less than IS2. IS1 never equal to IS2. Never related with the IS2.
So less than IS2, sir.
When the core is placed between them.
So when the core is placed between them, the current will be more. So IS2 will be more than IS1.
So IS2 will be more than IS1 when core is placed, right? And IS2 is due to core is placed, so IS2 always be greater than of IS1, right?
Yes, sir.
Very good. Now this is the picture which we are explaining. Which one? We explaining. দাঁড়াও আমার এটা চলে গেল হোয়াইট বোর্ডটা খুলি
স্যার বলছিলাম প্রোডাকশন ইঞ্জিনিয়ারদের মেনলি কি কাজ?
হ্যাঁ বলো।
স্যার প্রোডাকশন ইঞ্জিনিয়ারদের মেনলি কি কাজ?
প্রোডাকশনের
স্যার ওদের মেন কাজটা কি? মানে প্রোডাকশন বলতে কি বোঝাচ্ছে? মানে ওরা সব
quality control packaging industry, products restorations, management, অনেক কিছু আছে। প্রোডাক্ট ম্যানেজমেন্ট, কোয়ালিটি ম্যানেজমেন্ট, ব্রাঞ্চ অফ মেকানিক্যাল থেকে এসছে। আরে আবার ইয়ে কাজ করছে না, জামবোর্ডে আমি ইউজ করছি। এই জামবোর্ড কি নিতে পারবে না নাকি সবাইকে? 4 জনকে দেখাচ্ছে কেন? আমি জামবোর্ড ইউজ করিনি। I have no idea how it actually works.
মোবাইলে সম্ভবত জ্যামবোর্ড দেখা যায় না।
মোবাইলে জ্যামবোর্ড দেখা যায় না?
সম্ভবত, ঠিকঠাক জানি না।
ওই লিঙ্কটাতে গেলে তো একটা অ্যাপ ইনস্টল করতে বলছে।
হ্যাঁ, ডাউনলোড করতে বলছে।
করে দেখছি যদি দেখা। হ্যাঁ, ওটা করে দেখছি এখন আমরা ইনস্টল করে।
তো শিল্পী জয়েন করেছে দেখছি, সত্য গো। আরে আমার জানি না আবার কি হলো, আমি আজকেই ঠিক করলাম। এটা দেখা যাচ্ছে এখন?
সেটা দেখা যাচ্ছে কিন্তু মাল্টিপল উইন্ডো, মানে আপনার যেটা স্ক্রিন আছে ওটা মাল্টিপল স্ক্রিনে দেখা যাচ্ছে, ছোট ছোট করে হয়ে গেছে। আপনি শেয়ার
স্যার আপনি শেয়ার এন্টায়ার স্ক্রিন করে জ্যামবোর্ডে গেলে মনে দেখা যেতে পারে।
ট্যাব শেয়ার করতে হবে আপনাকে।
Is it visible?
Yes, sir. Yes, sir.
Through mobile? So look, this is Lvdt. And as I said, this is a primary coil, current is IP. Now core just between IP and core 2, I mean coil 2. If core is here, then the induction of the secondary coil will be high, right? Then the V2 or VS2 will be high because IS is high here. IS2 is high because core is now this positions, and IS1 will be less, VS1 is less. So at that situation, if core is here, V2 is greater than V1. Okay. Right, and vice versa is true for core is the first position means core is here. If core is here, then this will be induced more, and then V1 will be greater than V2. If core is here in second position, then V2 will be more, so V2 greater than V1. If we consider that two part, Lvdt concept, then probably it will be easier for us to understand what I said in last picture. What I said that was pasted in probably so we can say here now see the picture here, Lvdt. So you have seen the bottom gauge operation. So there will be a magnetic a iron core connected to the bottom gauge. Now once we will increase the pressure, bottom gauge try to be move up. I mean that bottom tube will try to move up. So the core will be close to the secondary coil and primary coil. Secondary coil 1 and primary coil 1. So voltage across secondary coil 1 is higher. When the pressure release, the coil comes to its initial position, then core will be present between secondary coil 2 and primary coil. Then the secondary coil voltage will be higher. Now that voltage we have here, that voltage will be here, and we put another electronics part, that is amplifier. Voltage amplifier means operational amplifier or inverting amplifier or non-inverting amplifier. These are the voltage amplifier. Now that voltage amplifier amplify that small voltage which is higher, because what the Lvdt actually give us differential voltage V2 minus V1, right? V2 minus V1. That expression you understood probably by the demonstration, videographic demonstration. I'll give you in details, but presently you just remember this part only, that when the coil presence between two primary coil and particular coil 1 or 2, then this voltage across this secondary coil will be higher value, and the resultant voltage will be voltage primary coil 1 minus primary coil 2. Sorry, secondary coil 1 minus secondary coil 2. That is the resultant voltage as the output of the Lvdt. So here resultant voltage is V2 minus V1. That is the difference between two secondary coil, and that voltage definitely is small voltage and amplified here by that operational amplifier and fed to a digital voltmeter. How it will be fed? As I said earlier, that we have to amplify the signal, we have to process the signal in more convenient and practical value, more convenient and practical value, which is comfortable for the next part or intermediate part of the instrument. Like here is a digital voltmeter. So what I have to do, we have to make the voltage convenient as if that digital voltmeter can measure and fed that signal to the external power source. That digital voltmeter is powered by external power source. Okay. Now this is the operation, and definitely this is secondary type of instrument. Primary coil is a primary instrument is a button gauge, which actually due to pressure try to be straightened, and due to variation of pressure, the button tube it tries to be straightened, and uh, the rest part is auxiliary part as well as the conditioning part is here. The auxiliary part and conditioning part and data presentation part is here. The voltage amplifier, we can say is a voltage amplifier, we can say it is a signal conditioning part, and voltmeter is a display part, data presentation part, and external power supply is the auxiliary part. Now come to that diagram. That is a block diagram. Block diagram, what it is said? Input energy signal. What is input energy signal here? Pressure signal. What is input energy signal? Pressure signal. Now what is primary sensing element or transducing element? Is a button tube. Button tube. Okay. Now what else they have said? Button tube is the primary element definitely, and it is interfaced or it is sandwiched with a LVDT. So button tube and LVDT sandwich both made a secondary instrument, but that too are considered as a transducing element. Okay, that too are considered as a transducing element. Then there will be signal conditioning part, that is the voltage amplifier part. Then digital voltmeter, data presentation part, and definitely there will be auxiliary power supply or auxiliary final element, a functional element. This is the block diagram of a button gauge. I mean secondary button gauge, which is interface with the LVDT to produce the electrical output, because you have seen that button gauge which purely mechanical instrument. Am I right? What you have seen
Yes,
in
sir. Yes.
pressure animation, the purely mechanical instruments. One pressure or once the button tube filled by the lube oil, it will be for generated force, or the tube will try to be tube of the tube will try to be move up, and that move up or moving that dynamic motion or that mechanical motion here converted in electrical output by LVDT. So it is a secondary instrument. It is not a primary instrument. But a primary instrument, which one is the primary instrument? You may say is a LVDT, button tube is the primary instrument. You may say also LVDT a primary instrument. But when they are clubbed, they are actually secondary instrument. Why? They are clubbed because we have to satisfy the condition of instrumentation. We have to produce the output in a more convenient and practical values. So that's why we club two instruments. But as we club two instruments, we can categorize as a secondary instrument. But when we are going to draw the block diagram by its functional element, so we can say there is a primary functional element here. Which one? Button tube and LVDT combinedly primary functional element or transducing element. Secondary is in element. Secondary is signal conditioning element or intermediate modifying element is signal conditioning electrical voltage amplifier that might be done by op-amp, and the further one is the basic functional element is a data presentations element, which one done by the multimeter, digital voltmeter or digital display. But here is also auxiliary power supply. This is external power element. Okay. Now, similarly, we will find some other instruments in our books. For galvanometer, will be a good instrument to explain. Should I explain it today?
So tomorrow.
Next class, sir.
Yeah, I feel bored also. Let me get your attendance here. 1 minute, hold on. So what I am finding here, Mohsin Mansoor, Jaydeep Maji, Sudha Sattvaguha,
Present, sir.
Nobirud Kavira, Somojit Acharya, Udbhas.
Yes, sir.
Don't need to yes
Okay,
or
okay,
no because I have taken a print skin. I have taken a print skin for your attendance, so don't need to say yes or no. But I am going to read out that Subhajit Mondal, Gulshan Poddar, Mainak Das, Sitama Ghosh, Silpa Mondal, Ankit, Surja Datto, Prasenjit Mondal, Anirban Naskar, Biplab Sarkar, Saurabh Seth, Sangram Saha, Soham Kanji, Sagar Chaudhuri, and Parvez Malik. Now, one thing more, if you have any kind of financial issue to recharge or not to recharge your mobile phone, or if you have any kind of problem with your mobile phone, but you cannot afford to buy it, then write a letter to me, or write a letter to intimate your seer about name, phone number, address, Gmail. Then seer will intimate you making a list. Okay, but find out yourselves that you should be honest here. If you have a financial crisis to reach for recharging your mobile phone, or you have a financial crisis to use a new mobile phone for doing class, then only you will get help from the university. Okay, you just get contact to keep contact with your seer and make a seer. Jaideep and others, please make a Google form. Although you have sent me a letter, send me a list of students, but I think this list was not honestly made. There's so many students are there who have a problem, but having problem means the university will not help you. The university only help you.
No,
if you
actually,
find
they
out-
have internet. Sir, they have internet connectivity problems. It's not about the financial crisis, sir.
Now, what I am asking right now, that you may have an internet connectivity problem, but university cannot install tower in your locality. What university is ready to do, if you have a financial crisis, you cannot afford to recharge your mobile or to buy a new mobile to do the class, then only university come ahead and help you. Okay, so you make that list honestly, as if I can pursue that list to the authority, as if the authority help you all. Help you those, help those students. Okay, if you have any problem with internet connectivity due to tower or due to some kind of other issue which is not related at all financial problem, we can't help. They need to move somewhere where the internet connection is good.
Sir, can we leave?
Yeah, you can leave.
Sir, Bolchi, hello, sir.
Yes.
বলছি স্যার ব্যবহার বলে একজন আছে আমাদের ক্লাসে, ওর চোখে একটু প্রবলেম হয়েছে, তো ও ডাক্তার দেখিয়েছে, তো ওকে বলেছে কি 2 to 4 weeks এর মতো ও ক্লাস যেতে না অ্যাটেন্ড করে, মানে স্ক্রিনের সামনে ও যদি চোখটা না ইউজ করে তো বেটার হয়। তো আমি হ্যাঁ, আমি ওকে বললাম একটা আপনাকে অ্যাপ্লিকেশন লিখে দিতে আর ওই প্রেসক্রিপশনটা দিয়ে দিতে, তো ওটা আমি আপনাকে ফরওয়ার্ড করে দেবো। Document
Joydeep, not only to me, you should send this one to every teacher of your class. Especially Ratna madam and Runu Banerjee.
না, রুনু ব্যানার্জি ম্যাম বা স্যার জানি না, তো উনি আমাদের এখন ক্লাস নিচ্ছেন না, মানে এই সেমিস্টারে নেই। এই সেমিস্টারে তো বিডি স্যার আছেন, এসি স্যার আছেন, রাতনাম দেখুন, নিতেশ স্যার আছেন।
Who is taking your circuit theory?
Circuit theory, Ratna ma'am.
Ratna ma'am.
Who is taking your linear control system?
Linear तो नहीं हमारे।
नहीं।
तो linear नहीं।
ना सर।
So next
Obhijit Chandra and
so electronics circuit.
Ratna madam, and all teachers. All teachers.
সবাই কি মেল করে দেবো? মেল করে দেবো?
Mail করে দিবে, when they will start the class, you must intimate that to things.
হ্যাঁ, মেল করে দেবো, ক্লাসের স্টার্টিং এ বলে দেবো।
হ্যাঁ স্টার্টিং এই বলে দিবে স্যার। হ্যাঁ ওকে
ঠিক আছে
মানডে আই হ্যাভ ক্লাস ওকে থ্যাংক ইউ আই উইল টেক দিস ক্লাস অন
স্যার মানডে সকালে হবে স্যার মানডে সকালে হবে না বিকেলে হবে
এই রে আমি সানডেতে তুমি একবার ফোন করো জয়দীপ। হ্যাঁ আমার যদি মানডে কোনো মর্নিং এ মিটিং না থাকে বা অ্যাপয়েন্টমেন্ট না থাকে আমি মানডে মর্নিং এ নিয়ে নেব।
হ্যাঁ 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 ঠিক আছে
ওকে
থ্যাংক ইউ স্যার